Srinivasa Ramanujan, one of India's greatest mathematician geniuses, was born in 1887 in Erode in Tamil Nadu, India. He is recognized as one of the greatest mathematicians of his time, but Srinivasa Ramanujan had almost no formal training in math. He was the second Indian to be inducted as a Fellow of the Royal Society, which is a fellowship of some of the world's most eminent scientists. He joined the fellowship in 1918 at the age of 31 as one of the youngest fellows in the history of the society. He compiled 3,900 results, which were mostly identities and equations, before he lost his life at the age of 32. His infinite series for pi was one of his more celebrated findings. There is also a museum dedicated to telling Ramanujan's life story. This is located in Chennai. His birth anniversary, December 22, is celebrated as a National Mathematical Day every year. Ramanujan worked on divergent series. He sent 120 theorems on implied divisibility properties of the partition function. He gave a meaning to Eulerian second integrals for all values of n, negative, positive, and fractional. Ramanujan made substantial contributions to the analytical theory of numbers and worked on elliptical functions, continued fractions, and infinite fractions. In 1990, he began to work on his own on mathematics, summing geometric and arithmetic series. Goldbach's conjecture is one of the important illustrations of Ramanujan's contribution towards the proof of the conjecture. The statement is that every integer greater than 2 is the sum of 2 primes. For example, 6 is 3 plus 3. Ramanujan and his associates had shown that every larger integer could be written as the sum of at most 4. Example, 43 is equal to 2 plus 5 plus 17 plus 19. Partition of whole numbers. The partition of whole numbers is another problem that captured Ramanujan's attention. Ramanujan also developed a formula for the partition of any number, which can be made to yield the required result by a series of successive approximations. Example, 3 is equal to 3 plus 0 is equal to 1 plus 2 is equal to 1 plus 1 plus 1. Ramanujan also studied the highly composite numbers, which are recognized as the opposite of prime numbers. He studied their structure, distribution, and special forms. The Fermat theorem. Ramanujan also did considerable work on the unresolved Fermat theorem, which states that a prime number of the form 4m plus 1 is the sum of 2 squares. Ramanujan number. 1729 is the famous Ramanujan number. It is the smallest number which can be expressed as the sum of 2 cubes in 2 different ways. 1729 is equal to 1 cubed plus 12 cubed is equal to 9 cubed plus 10 cubed. Cubic equations and quadratic equations. Ramanujan showed how to solve cubic equations in 1902, and he went on to find his own method of solving quadratic equations. Euler's constant. By 1904, Ramanujan had begun to undertake deep research. He investigated the series of 1 by n and calculated Euler's constant to 15 decimal places. Hypogeometric series. Ramanujan also worked on hypogeometric series and investigated relations between integrals and series. He was to discover later that he had been studying elliptic functions. Ramanujan's own work on partial sums and products of hypergeometric series have led to major development in the topic.